Hi, this is GeneScope. Overall, genomic AI pipelines are fragile, and errors from reference drift, color versions, or even annotation mismatches can silently cause wrong results, and this can contribute to wasted trials and, most importantly, patient risk. What GeneScope does is it's an investigator against genomic pipeline drift. When systems detect instability or drift, instead of just flagging errors, the investigator agent evaluates hypotheses, builds a knowledge graph, and actually takes efforts to remediate the issue. The process starts with hypothesis generation. When an anomaly is detected, the agent enumerates possible causes across each pipeline stage of sequencing, variant calling, annotation, and prediction, and these hypotheses are ranked with confidence so that the order of traversal can be established. Next comes evidence collection, and so for each hypothesis, the agent runs real probes. For example, if it suspects reference drift, it might realign against GRCH37 and GRCH38, and each of these probes is run directly as backend code, and the results are attached as evidence nodes in the dynamically changing knowledge graph in the upper left corner. Afterwards is the most important stage, which is remediation. So once weak branches are pruned, and once a hypothesis is strongly supported, GeneScope doesn't just stop at pointing to the problem, it actively tests fixes. And for example, if the issue is an annotation schema drift, the backend would execute reannotation with pin database versions by running VAP commands in the live terminal, as can be seen. And overall, there are different efforts that can be taken based on the context of the evidence and of the hypothesis, and the agent intelligently figures out which to execute and evaluates the effectiveness of its remediation efforts. Each remediation effort also becomes a validation node once it's executed, so that you can see how the effort of the investigator agent has been evolving over time and over hypotheses. Once the agent finally converges on a hypothesis and a successful remediation effort, then an entire report is generated, and it is clearly defined where and how the problem was detected, and exactly how efforts to remediate were taken, and how in the future problems like these can be prevented. This can contribute greatly to reducing drift and instability in these genomic AI pipelines and preserving patient safety at the end of the day. Thank you.